Hi there. Today, I will teach you the basics needed for Pythagorean theorem and similar triangles. It includes history, the formulas, how they work and where they're used. Let's go. First, let's start with the history of Pythagorean theorem. Pythagoras was a Greek philosopher that created Pythagorean theorem. He lived 569 BC to 500 BC. Ancient clay tablets from Babylonia in the 2nd millennium BC, 1000 years before Pythagoras, indicate that the people understood right triangles. This includes the relations between the sides of a right triangle. Next, let's talk about the formula. It's a square plus b square equals c square. This formula is used to find the hypotenuse of a right angle triangle. Now let's learn the steps. There are 3 sides of a right triangle. A and B are the legs. C is the hypotenuse. The hypotenuse is always the opposite side of the right angle. Next, use the formula. 3 square equals 9. 4 square equals 16. 16 plus 9 equals 25. Then you find the square root of 25, which is 5. So, C is 5. You can also use Pythagorean theorem to find a leg of a right triangle. The formula would be c square minus a square equals b square. Again, use the formula. 3 square equals 9, 5 square equals 25. 25 minus 9 equals 16. Then you find the square root of 16, which is 4. So, b is 4. Finally, let's talk about where it's used. It's used in architecture and earthquake location. Geologists use the formula to detect the center of the earthquake. Now on to similar triangles. Since there isn't really any history, let's start with how it works. Similar triangles are related by proportion. The angles are the same but the side lengths differ. Triangles can be of any kind including acute, right and obtuse. These are 2 similar triangles. They have the same angles but different side lengths. This is what these similar triangles would look like without values. This is what they look like with values. Notice how A and B have not changed. Now I will teach you how to find their values. Let's start with how to find A. When finding A, we will use the same formula as Pythagorean theorem. So write it out like this. A square plus 6 square equals 10 square. A square equals 10 square minus 6 square. A square equals 100 minus 36, which equals 64. So A square equals 64 and the square root of it is 8. So, your answer for A is 8. Now, let's find B. First, you write out 10 over 5 equals 6 over B. Then, you cross multiply. 10 times b and 5 times 6. The answer is 10b equals 30. Then you divide both by 10. So b equals 3. Here is the final product of both triangles solved. And that is how to solve similar triangles. We're almost done here. Finally, let's see where similar triangles are used in daily lives. They are used in aerial photography to measure the distance from the sky to the ground. It is also used in light beams to see the distance from the light to the target. See, that wasn't long, was it? Hopefully you learned what you needed to about Pythagorean theorem and similar triangles. Now it's time for me to go. See you next time.